So this is our Unit 2, Section 4 video, and we're going to do compositions of transformations today. So our objective is to apply the theorems about isometries and to identify and draw compositions of transformations, such as a glide reflection. So our vocab is composition of transformations and glide reflection. So our first term here is, sorry about that, is a composition of transformation. This is when when one transformation is followed by another. So we're going to do more than one transformation in a problem. An example of this is a glide reflection. It's a composition of translations of a translation and a reflection across a parallel line to the translation vector. So an example of this here is JKL translates to be sorry about that. I wanted to do that in green. Sorry. Translates to be J prime, L prime, K prime. When we translate it, that's what it becomes. And then when we get down here to our reflection, we're going to have K double prime, L double prime, and J double prime. And that's because we translated it first and then we reflected it. So the image after each transformation is congruent to the previous image. So that means if I have image A is congruent to image B and image B is congruent to image C, then image A is congruent to image C. That's the transitive property of congruence. So that's one of our ways of saying that those two shapes are congruent. So I'm going to walk you guys through this one, and we're going to talk through it. So we have this shape ABCD right here, ABCD, that shape right there. And then we see it's transformed to be ABCD prime. So most of y'all can look at that and tell me that I think that that's a rotation because it obviously turns. However, we can test this. So we're going to take one of these points, and I'm going to use point C prime and C right here. These 2 points to do that. So I'm going to look at C, and C, if you notice, is 1, 3. And then C prime is -3, 1. Now I wouldn't do this with a point that's the same, like 1, 1 or 2, 2. I would choose a point that has different numbers for the X and Y coordinate. So notice now that we should be able to see that the transformation that took place here, you should be able to see that X and Y swapped places and that our Y value became negative. Now all of you should know by now that that is a 90-degree rotation. So on y'all's paper, y'all, you should be writing this. This is what's in that blank. What is that rule for what happened first? Then we should be able to look at what happened second. And I taught y'all that if we draw these lines from our common vertices, D to D, B to B, A to A, you guys should all see that those lines are all parallel and they are congruent. And that tells me that this is a translation. Now we're going to determine what kind of translation is it. So we're going to take our C prime, which we already have the number up there for, it's -3, 1, and we're going to compare it to C double prime. And that point is -4, 3. So now I want to ask you, to get from this -3 here to the -4 there, what did we have to do? So I'm going to create a vector that tells me that. We had to subtract 1, right? To get from the 1 here to the 3 there, we had to add 2. So that's a +2. So that is a vector. And that vector is what allowed me to translate from C prime to C double prime. And so the rule for this one is X minus 1, comma, Y plus 2. That tells me that this image moved 1 to the left and 2 up, and that's exactly what happened with it. So that's our process for how we do this type of problem to determine what actually happened. Okay, the one thing I want to tell y'all is when we're doing compositions of transformations, order matters. So y'all need to write that on your paper. It's very important. So here it tells us triangle KLM has vertices, and it tells us K and L and M. And then that it rotates 180 degrees about the origin. So we know it's rotating 180 degrees. and then it's going to reflect across the y-axis. So the order that this is given in is the order that we have to do the problem. So we're going to rotate 180 degrees first, and then we're going to reflect it across the y-axis. So we're going to work the problem now. So that's our rule for a 180 degree rotation, negative x, negative y. So that means all my points that I already have, I'm just going to change the signs of all of them. And I'm going to get a k prime, an l prime, and an m prime. So if you recall, I told you guys that I want you to write the rule, apply the rule, and then plot the points. So write the rule, apply the rule, and then plot the points. This is your process. Okay, so we've already written the rule, we've applied the rule, and now we're going to plot our points. And we could have guessed that this was going here because this is a 180 degree rotation. So we started out in the fourth quadrant, so we should be going to the second quadrant. Now the next one was a reflection over the y-axis. So this is going to be a change in x. So here again, we were over here in quadrant 2, and if we're reflecting over the y-axis, we're expecting this image to go that way. So it's going to take us, sorry, that was 2. We're just going to take us to quadrant 1. So here again, we're going to change all the signs of the x values. That's what we did here, and then we're going to plot our points. So again, write the rule, apply the rule, plot the points. And indeed, it went exactly where we were expecting it to go. All right, so here's our check it out. Go ahead and do this one and then come back to me when you're done. So here again, our first step, what we need to do is talk this through. So we're reflecting across the x-axis. That's our first rule. Then we're going to rotate 180 degrees. So this time we're going to write our rule for reflecting across the x-axis. So we reflect across the x, that means we're changing the y. So our rule is x negative y. So we're going to basically change all our y values to whatever they're not. So if they are negative, they're going to become positive. If they're positive, they're going to become negative. So I went ahead and did that, and my points are already plotted on mine. And again, we reflected across the x-axis. Here's the x-axis. We started in quadrant 4. We expected it to go to quadrant 1 because that's a reflection over the x-axis. Now our next one says rotated 180 degrees. So we're in quadrant 2. And if we're rotating at 180 degrees, we're expecting it to go down here. And indeed it will, as you will see. So that's going to be negative x, negative y. So that's negative 1, negative 2. So basically we change the sign of everything. Now remember, when you guys do this, the one thing that's not on my drawing that y'all need to remember is make sure you label these points. So this is going to be your L prime. This is your K prime. This is going to be your J prime. And our red one over here, again, is going to be J prime, double prime, K, double prime, and L, double prime. So those are our points. Make sure you label them when you guys are doing these problems. All right, so next problem is this one. So again, I want you guys to go ahead and do this and then come back to me when you're done. So this one, we started out with this image right here. And it tells us again up here that we're going to rotate 90 degrees, and then we're going to reflect over the x-axis. So our rule for our 90-degree rotation is negative yx. Means we're going to flip our points, and then we're going to negate what's in that first position. Notice we flipped them, and we made all of these negative. And then on the second one, we're doing a reflection across the x-axis. That means we're changing y. So we're then going to make all of these values negative. And here again, a prediction. So if we start out in this first quadrant and we're reflecting across, rotating 90 degrees, we're going there. That was our thought. That's what our prediction should be. And then if we're reflecting across the x-axis, we're going to go below the x-axis. So we should be able to make predictions with these every time. That's a great way to determine whether we did the problem right or wrong. All right, So any translation or rotation is equivalent to a composition of two reflections. So anytime you use a double reflection, there should be a rotation about the intersection of the reflection lines that maps the pre-image to the final image. And in the following example, we're going to talk about what the rotation is after we do it. So here we have A, B, C, D, and it reflects over the y-axis. And then we have A, B, C, D prime. And let me go ahead and put these points on here. So this one would be A prime, D prime, C prime, and B prime, right? And then down here on the bottom, we've got our double primes. So this is going to be our B double prime, our A double prime, our C double prime, and our D double prime. Now, one of the things I want to talk to y'all about is that I can figure this out almost by looking at it, but I can also figure it out by using just one of the points. I'm going to show you with all the points, but I'm also going to show you with one point. So when I do this, I can compare one of my points towards another. Now here again, don't do this with 2 points that are the same. Do it with ones that are different. So in other words, I wouldn't use 2, 2 or 1, 1 here, so I wouldn't use A or B, but I might use D or I might use C. So let's go ahead and use D. So if I look at D and I'm going to compare it to D prime, or D double prime. So D is 1, 4. And then D double prime down here at the bottom, that's this point down here, is -1, -4. Well, hopefully all of y'all can already see that the transformation rule that would apply here is -x, -y. And hopefully all of y'all know at this point that that is a 180-degree rotation. So I can use more than one point to prove this fact, but what I like to look for is a point that basically is not the same number twice, and then I can just do that. I could do it with more than one just to verify that. But notice here again, this is going how far? 180 degrees. Do y'all notice that? The diagram is going 180 degrees. So let's walk through what's on y'all's notes. So here on y'all's notes, you will notice that we thought that it was a reflection over the y-axis, went ahead and did that. Then a reflection over the x-axis, right? That's what those were. It's what it says in the problem. But then when we compare that, we realized that it was a 180-degree rotation. So y'all can pause this, go ahead and fill in your blanks, and then move on to the next problem. So this one here's your check it out. So again, I want you guys to compare the blue to the green to the red. So it says reflect the square over y equals x. That's going to take us from the blue to the green. Then reflect it over the x-axis. And it's asking, is there one rotation that will take the pre-image to the final green image? So here again, we're going to do all that. Yx, make them swap positions. That's our rule for the reflection over y equals x. Then we're going to do the reflection over the x-axis, which is x negative y. Remember, reflection over the x is change in y. So what I want to do right now too is compare some of these points. So let's start with just one of our beginning points. So let's look at 4, -6. So that's this point right here. Y'all see this? We're going to compare that to our last point, which is this one right here. So we've got 4, -6, and it becomes what? -6, -4. Okay, so you should immediately notice that the x and the y swap. Hopefully all of y'all can see that. So this is going to be yx. We know that for sure. Now, which one of the signs changed? The 4 changed to a -4, right? So that's going to be this right here. So now we need to look at that and determine what rule is that. Well, I know that that's a 270-degree rotation. So here again, if you notice, how far did it go? It went 3 quadrants. So if it went 3 quadrants, it is 270 degrees. So we know that this is a rotation that's 270 degrees counterclockwise, and that's a normal rotation. We could also say it's a 90-degree clockwise rotation. So here's our next one. We're going to rotate JKL. Actually, we already did this, so I'll go over it anyway, but our rule here is y negative x. We're going to apply that rule to all our points, and then we're going to rotate it. Here again, this is another 270-degree rotation. Y negative x. Go ahead and apply it to all our points. Plot our new points. These were just extra practice on 270-degree rotations, y'all. That's all.